Hello. Let's start with section 5.1, exponential function and their graphs. So before moving on, we already learned how to graph polynomial function and how to graph the rational function and polynomial function and rational functions, these types of algebraic functions. Now we're going to learn how to graph or solve exponential functions or exponential equations. And this type of equations is called non-algebraic equations or functions. So the exponential function of f with base a is denoted by. So f of x equal a to the exponent x, where a is greater than 0, which is the base, a not equal to 1. So we're going to work with 2, 3, 4, 5, and a and x is a real number. So x is a real number, which is the exponent. So now we have, I'm going to write down 4 types of like basic graphs of exponential function. Always a, we're going to say x greater than 0. We're going to work only with this one. So the first one, if you have f of x, a to the x, always a is an integer number. So we're not going to work with decimals with these 4 graphs. Maybe you're going to get 0.2 when you work on the assignments. But with these 4 graphs, always a is an integer number. So if a is greater than 1, but the exponent is greater than 0, that means positive number. So that's how it looks like the graph. The domain always negative infinity to positive infinity, the range from 0 to infinity. Y-intercept is going to be 0, 1. No x-intercept, because the x-intercept is going to be an asymptote, continues always on the entire domain, and the function is increasing. If a is greater than 1, that means 2, 3, 4, 5, 6, but the exponent is less than 0, which is negative number. That's how it looks like the graph. The domain negative infinity to positive infinity, the range is 0 to infinity, y-intercept 0, 1, no x-intercept, and the function is going to be continuous, but it's going to be decreasing. The function is going to be decreasing. That means if you took 2 points from this function and find the slope is going to be negative. So this is the first 2 types. Now I'm going to add 2 more. This is just going to help you when you graphing. If a is less than 1, that's mean negative number, but the exponent is positive, greater than 0. That's how it looks like the graph. The domain negative infinity to infinity, the range is going to be negative infinity to 0, because you see the range from negative infinity and stop until the 0. Y-intercept is going to be 0, negative 1. Again, no x-intercept. The function is going to be decreasing and continuous. If a less than 1, that means less than 1, but the exponent is negative number. So that's how it looks like the graph. The domain is going to be negative infinity to infinity. The range is going to be negative infinity to 0. Y-intercept is going to be 0, negative 1. No x-intercept, and the function is going to be increasing. That means if you took 2 points from the graph and find the slope is going to be positive sign, and this function is going to be continuous. Now the natural base E. This is the natural base. So if you look to the calculator, you will see an E by itself. Let's check here. E by itself, which is equal to this amount, 2.71828. This is the base E, which is a fixed number or just this number. What about if I have function f of x equal e to the x? This is called a function with the base e, or the natural base e. How to graph this one? It's a part of the exponential function, but we have the base now e, which is this number. So if x is greater than 0, that means positive number. That's how it looks like the graph. Here's the intercept 0, 1, and the domain and the range here. Let's learn how to graph it. So we're going to go to the graph, y equal and you're going to plug in how to plug in the base e. So we're going to press on the second, and you see the ln here, ln. This is e to the x. So I'm going to press e. Now I have to write down the x. Here is the x, e to the x. Click on the graph. Now the graph of the function is going to be like this. If you want to see the intercept, the y-intercept, you're going to click on the second and now check the table. So if you see when x is 0, y is 1. That means this is the y-intercept. There is no x-intercept. If you look at the whole table, you're not going to find a value for x and y equals 0 because there is no x-intercept with this one. The domain negative infinity to infinity and the range from 0 to infinity. The same thing if you have negative x, that means we're going to go back here to y equal. I'm just going to add here negative. This is the negative sign. You're not going to put minus. And here is the x. Then graph it. The graph is going to be on the opposite side. That's what we have here. And let's look to the intercept second table. So the intercept is 0, 1. So that's our intercept. And the domain from negative infinity to infinity and the range from 0 to infinity. So that's how to graph the exponential function. Let's move to the next part. This is really important note. To solve exponential equation, you have to use one-to-one property. One-to-one property, that means if you have equal bases, that means you have equal exponents. Equal bases, that means these bases are the same. So that means we have equal exponents. Again, equal bases, that means we have equal exponents. Now let's check some rules about applications to find the future amount in your bank account. We have two formulas. The first formula here is A equal P, 1 plus R over N Tn. A is the balance in your account after a certain time. P is the principal, which is the deposit or the invest. R is the rate of interest. T is the time. N is the compounding per year. Compounding per year, if they're telling you annually, that means N equal 1. That means you're going to plug in 1 here instead of the N. Semi-annually, that means N equal 2. Quarterly, N equal 4. Monthly, N equal 12. Daily is going to be 365. Hourly is going to be 8,760. So when you hear one of these words, this is the value of N. If they're telling you continuously, that means you're not going to use this formula, you're going to use this formula. A equal P E R T. We're going to do some examples about this one when we start working on the assignments. So let's start from example 6. So example 6, we have, they ask you to evaluate the function at the given point or given value of x, round the result to 3 decimal places. So f of x equal 0.5 to the x, 0.5 to the x, and x equal 1.8. So how are we going to evaluate? That's mean f to the x 0.8 equal. I'm going to plug in x here. So 0.5 to the 1.8. So let's check how we're going to work on this one. So we're going to go here and plug in 0.5 to the exponent 1.8 because it's just evaluate 0.5 to the power 0.8. So it's going to be, the result is going to be 0.287, round to 3 decimal places. So 0.287, here's 1, so I'm not going to change the 7. So 287. That's it for this example. So we're just going to type here 0.287. 287. That's it for this example. The same thing with example 7. So example 7 is, there's example 7. Come on. Example 7 is also evaluate, but now we have f of x equal 5.6 to the power x, 5.6 to the power x, and they're telling you x value is negative pi. So that means we're going to plug in f to the negative pi instead of each x. That means 5.6 to the negative pi. Now let's check here in the calculator. Where you're going to find the pi. And be careful, it's negative. So 5.6 to the power. Here is the negative sign, always, not the minus. Negative sign. And the pi is going to be here. You're going to click the second and the exponent, the arrow. So you're going to click the second and the arrow is going to be pi. That's mean negative pi. Hit enter. So it's going to be 0. The result is going to be 0.004. Because they ask you to round to 3 decimal places. And after the 4 is going to be another 4. So it's going to be 0.004. So we're going to type here just 0.004. This is this example. For example 8, now we have g of x equal 8,000 and 2 to the x. And they're telling you the value of x equal negative 2.5. So how are we going to evaluate this one? We're going to plug in this number here. That means g of negative 2.5 is going to be 8,000. And here's 2 to the negative 2.5. So let's plug in here. That's mean 8,000. I'm going to open parentheses, 2 to the exponent, negative 2.5. Go down and close the parentheses. So the result is going to be 1414.213. If you look here, 213. They ask you to round 3 decimal places. So it's going to be 214 because there is number 5 here. We're going to add 1 here. So 214. 1414, 214. So we're going to type here 1414.214. That's it for this example. So for example 9, they're telling you use the graphing utility to figure out this table. That's mean we have table, and that's the way to graph the exponential function. You have to pick a point from the domain and plug in these points to get the y, and then grab the point. But now they give you the value of x. They're telling you -2, -1, 0, 1, 2. So, but to graph any any exponential function, you're just gonna take any points from the domain, and the domain is from -infinity to +infinity. Plug in these in the function to get the y. Now we're gonna work with this function 2 to the power x. So the first one is going to be 2 to the power -2, which is equal 0.25. The second one, we're gonna plug in -1. So it's gonna be 2 to the exponent -1. And the result is going to be 0.5. Now we're gonna plug in 2 to the exponent 1. 2 to the exponent, 0. Forgot the 0. 2 to the exponent 0 always is going to be 1. Any number with the exponent 0 is going to be 1. Now 2 to the exponent 1 is going to be 2. 2 to the exponent 2 is going to be 4. So here is the value for this table. And then on the same time, I'm gonna use I can graph these points because now I have points, which is -2 and 0.25. And the second point is -1 and 0.5. The third one is 0, 1, which is the y-intercept, and 1, 2, and 2, 4. So now these are the points. If you graph it, you're gonna get the graph of the function. But I'm gonna plug in here 0.25, plug in here 0.5, plug in here 1, plug in here 2, and plug in here 4. Then now, if you just look into the notes, you're gonna figure out which one is the right graph. This is the y-intercept, 0, 1. So there is no y-intercept here, 0, 1. The y-intercept here is 0, 3. So this is wrong. There is no y-intercept here. No, the y-intercept here is 0, 0, which is wrong. There is no y-intercept on this graph. So the y-intercept is 0, 0. I'm gonna cross it. The y-intercept here is 0, 3. So I'm gonna cross this one. The y-intercept on this one is, let's check here. The y-intercept is 0, -1. So also I'm going to cross this graph. Check the y-intercept here is 0, 1. So this is the right option. If you want to make sure this is the right one, let's graph it. So I'm gonna say 2 to the power x, 2 to the power x. Graph, and the graph of this one is going to be here. Now let's check the table, the second function, and you're gonna click on the graph. You see the point 0, 1. The point 1 is going to be 2. If you go up, the point -1 is going to be 0.5. Go more up, the point -2 is going to be 0.25. So that's it for this example. We're just gonna choose this one and submit. Let's go to example 10. I think example 10, the same thing. So example 10, you're gonna do the same thing, and then, but you have -x. So I'm not going to do this example. Let's go to example 11. And let's work on this example because this is important how you're going to plug in these two numbers. So you have two options, and then let's find out. So example 11, I think example 12, the same thing. Yep, 1/2, and that's different. So let's work on this one. Let's look like evaluating the function. So let's check here. Example 11, we have f to the x equal 2/5 to the negative x. Again, you can graph it and find the table. You can find these values, but I prefer to practice about evaluating. So let's create this small table with x value to find the y value, and we have -2, -1, 0, 1, 2. So let's learn how to plug in on this function. So I'm gonna plug in -2 here. Be careful, there is negative sign here. So it's gonna be -2 times negative is going to be +2. So because when you plug in, it's going to be 2/5 to the -2. That means it's going to be +2. So that's, you have to be careful. I'm going to open parentheses. I can type it as a fraction, or you can, let's see if you type it as a fraction. I think alpha, this one, no, you can't. Here. Anyway, so you can type it because this is a graphing calculator. 2 divided by 5. You can type it like this. It's going to be fine. Close the parentheses. To the exponent, negative times negative is going to be positive. So it's going to be +2. And the result is going to be 0.16. So with the first one, it's going to be 0.16. Now, -1 is going to be -1. So it's going to be +1. That means 2 divided by 5, close the parentheses, to the exponents 1, which is going to be 0.4. So this is 0.4. Now to the 0, 2 divided by 5, close the parentheses, to the exponent 0. Any number to the exponent 0 equal 1, which is the y-intercept. Now 2 divided by 5 to the exponent. Now 1, plug in the 1 here, is going to be -1. And the result is going to be 2.5. Now plug in 2, so 2.5 to the exponent -2 is going to be 0.16. Let's check. Okay. Now here's this point. Let's check the graph if we want to graph it. So we're going to type here, clear this one, parentheses, 2 divided by 5, close the parentheses, to the power negative, and here's the x. Let's grab the table, and the function is going to be like this. This is the 0, 1. So now we can know which one you're going to choose by just looking to this point, the y-intercept. Now check the table. The table is going to be, so let's look here. -2, 0.16, -1 is going to be 0.4, and 0, 1. 1 is going to be 2.5, but with the 2, we got something wrong because it says 6.25. Let's check what the wrong thing I did. 2 is going to be -2. Well, this is something wrong. So let's. There's something wrong with this one. 2.5 outside. That's what is wrong. 2 divided by 5 to the exponent -2. 6.25. So this one is 6.25. That's make more sense. Because I got exactly the same number, which is wrong. 2, 5. Okay. So now we already know which one is the right graph by just looking to the, could be this one, could be this one. So when you graph it, which graph we got? 2 divided by 5 to the exponent -x. Graph it, we get the graph, this one. That's mean I can't choose this one. I can't choose this one. I can't choose this one because the intercept is 0, 3, which is wrong. That's the only right option. And I'm not gonna plug in these numbers. That's it. Example 12 is going to be the same thing. Example 13 is exactly the same thing, but now we have different type of functions. So be careful here, because it's a +4 is not an exponent. So when you graph this one, example 13, you just have to be careful, because f to the x is going to be equal 2 to the x plus 1 plus 4. Plus 4 is not an exponent. So let's see how it's going to be the table. This is x. We need to find the y. And the point is -2, -1, 0, 1, 2. Now let's check by plugging this number to find the y. So the first thing, we're going to plug in -2 here. So it's going to be 2 to the exponent -2 plus 1. I'm going to go down now here. I'm going to say plus 4. The result is going to be 4.5. Now I'm going to plug in -1. So 2 to the exponent -1 plus 1. Go down here plus 4. It's going to be 5. Plug in the 0. So it's going to be 2 to the exponent 0 plus 1. Go down here plus 4. And the result is going to be 6. Now plug in the 1. So 2 to the exponent 1 plus 1. Go down plus 4. And the result is going to be 8. Plug in 2. So 2 to the exponent 2 plus 1. Go down plus 4. And the result is going to be 12. So we're going to plug in here on the table when it's -2. So it's going to be 4.5. When it's -1, it's going to be 5. When it's 0, it's going to be 6. You see the y-intercept? 0, 6. When it's 1, equal 8. When it's 2, equal 12. Sorry. Now let's check which one is going to be the right graph. So 0, 6 is the y-intercept. So I'm going to look, first of all, to the graph with the y-intercept 0, 6. This is not, because this is the y-intercept here. This is 0, 6. This is not. So it could be this one or could be this one. So let's check. When it's -2, When it's -2, the y is 4.5. So let's check. So when it's -2 here, y equal 4.5, which is almost here, because this is the 5. When it's -2 on this graph, y is, you can tell. Let's check another point. When it's 1, y equal 8. This is 1, y equal 8 here. So this is the right graph. By just figure out these points without a graphing, we figure out this is the right one. So let's make sure this is the right one. So what we're gonna do, we're gonna graph our function. So y equal 2 to the power x plus 1, go down plus 4. Graph, and our function is going to be, look, going up. You can zoom out. Zoom out more. Let's zoom out. So this is the right graph, which is exactly what we did. We chose this one. That's it for this example. Example 14, now we need to use one-to-one property to solve the equations for x. We have 2x plus 2 equals 16. 2 to the exponents, x plus 2 equals 16. The one-to-one property, it means if you have equal bases, that means you have equal exponents. Equal bases, it means you have equal exponents. So what we're going to do here, I need to get equal bases because I need to find the value of x, and x here is on the top as exponents. So here is 2x plus 2 equal. I'm going to analyze this one or factor the 16. 16, I can write it down 2 times 2 times 2 times 2. That means 16, which is equal 2 to the exponent 4. That means I'm going to write down here 2 to the exponent 4. If you look here, what we get equal bases. Equal bases, that means I have equal exponents. So I'm just going to take down from here the exponents and take down from here the exponents. I'm going to say x plus 2 equal 4. Now this is linear equations, is easier to solve. -2 from both sides. In this case, x is going to be equal to. So here's our solution. So we solve the examples by using one-to-one property. Our solution is going to be x equal 2. The same thing with example 16, 14, 15. Example 14, 15. We have 4 to the power x minus 7 equal 16. I'm going to do exactly the same thing, but if you look here, the base is 4. Can I write down the 16 as 4 to the exponents? So if you look, 16 equal 4 times 4. Then I'm going to write down 16 as 4 squared. So now 4 to the x minus 7 equal 4 squared. In this case, we have equal bases. That means equal exponents. So I'm going to write down the exponents from here and from here. That means x minus 7 equal 2. Solve this one. You're going to add 7 to the both sides. So x is going to be equal 2 plus 7 is going to be 9. That's it for this example. We're just going to type 9. Let's look to the next example, example 16. Can we do the same thing? When they ask you solve, and you can see it's an exponential function. The only method to solve this one is equal bases. That means equal exponents. So now 16, we have 1 over 4 to the power x equals 64. Now I need to get equal bases. That's my goal. For this side, 64 is equal, I can say 4 times 4 times 4. 4 times 4 is going to be 16. 16 times 4 is 64. That means 64 is 4 cubed. This is the right side. But if you look to the left side, 1 over 4, there is one of the exponents rule. It says if you have 1 over a number with positive exponents, is going to be the number with negative exponents. I have 1 over 4. The exponents here is 1. So I can say that this is 4 to the negative 1, and here is the x. Here is the equal sign. Now I didn't finish because I have 2 exponents here. There is another of one of the exponents rule. Another one is if you have a number with n and m, 2 exponents, you're gonna say it's the number with n times m. That means you can multiply the exponents. That's what I'm going to do here. It's 4. Negative 1 times x is going to be negative x equal 4 to the exponents of 3. Now we have equal bases. It means we have equal exponents. So I'm going to write down the exponents here and write down the exponents here. So a negative x is going to be equal to 3. I need to find the value of x, so I divide both sides by negative 1. That means x is going to be equal to negative 3. So this is the solution for example 16. Let's work on example 17. We're going to do exactly the same thing. So example 17, now we have the base is 5. So I'm going to work on this one. 25, we can write down the 25 as 5 squared, which is 5 times 5. So on the left side, here is 5 to the exponent x minus 4 equal 1 over 5 squared. Then if we have 1 over a number with positive exponent, is going to be the number with negative exponent. That's mean 5 to the exponent x minus 4 equal, bring that, this one is going to be 5 to the negative 2. Now we have equal bases. It's mean we have equal exponents. So in this case, you're going to write down the exponents. X minus 4 equal negative 2. Now we're going to add 4 to the both sides. X is going to be equal to. That's it for this example. So we're just going to type 2 here, x equal 2. Example 18. Now we're going to evaluate, but we have the exponential function with the natural base, e to the x, and evaluate at the point 2.2. That means f to the x equal e to the x, and they're telling you evaluate when x equal 2.2. That means f to the point 2.2 is going to be e to the exponent 2.2, which is equal. Just gonna go ahead here and say The second len, here is e to the x, 2.2, which is equal 9.0250. They ask you to round to the 3 decimal places. So it's going to be 9.025. So I'm just gonna type here 9.025. The same thing with the next example, example 19. So I'm gonna go to example 20. Example 20. 20, we're gonna graph it. So now we're gonna evaluate on the same time, and they're telling you use the graphing utility. That's mean, first of all, evaluate, then graph it. So let's check this one. We have f of x equal 3 e to the x plus 1. Let's check the table x, and here is y. We're going to evaluate each value. So -3, -2, and later on -1, 0, 1. Let's evaluate. That's mean 3, the second function, which is e to the x. Now x is -3, so -3 plus 1. How much is going to be the value? The value is going to be 0. And they ask you to round to 3 decimal places. So it's going to be 0.406. 0.406. Now let's plug in the second function here. We'll change -3 to -2. And this one is going to be 1.104 because this is 6. So 1.104. I'm rounding the number. Now plug in the same function and change the 2 to 1. So it's going to be -1. Then it's going to be 3. At 0, so here is the function. Now we have, instead of -1, we're going to put 0. So you have to delete this number. And the result is going to be 0.15. 0.15. This is the y-intercept. Now at the point 1, so now instead of the 0, we're going to put 1. And the result is going to be 22. So here's, we're just going to fill 22.3 decimal places. So 167. 167. So at -3 is going to be 0.406. At -2 is going to be 1.104. At -1 is going to be 3. At 0 is going to be 0.15. And at 1 is going to be 22.167. 67, not 76, yes. So now, which one is going to be the right graph? So we can graph this one. We're going to go to the y, clear everything here. 3 to the exponential function, and the exponent is going to be x plus 1. The graph is going to be, this is the graph, and you can tell this is the intercept. The intercept, so here is the right graph or this one. We can't tell which one is going to be the right, but we're going to depend about the intercept, which is 0.15. Here's 0.15. Check the intercept here. The y-intercept is 5, 6, 7, 8. So this is wrong. But this is, here is the y-intercept is 0.15. You can't tell because this is 5, 1, 2, 3, 4. No, because the scalar here is not, goes by 1. If you check the table, 0.15. This is the x-intercept. So we're just gonna choose this one as a right graph, and that's it for this example. Sorry, I did something wrong because I thought it's 0.15. 0 point is 8.15. It's 8.15. And 3 decimals, so 1548, so 155. So that's totally changed the whole thing. I thought it's 0 because it looked like 0. So here is going to be, that's why they're telling me it's wrong, 8.15155. Now this is changed the whole thing. That means 0 is 8, it's going to be, this is the right graph. Because we have a 5, 6, 7, 8, which is not 8, it's 8.155. We have to choose this one. Even if you check the table, yeah, this one is 8.15. Now this is the right graph. The same thing with example 21. Let's go to example 22, which is we're going to use the one-to-one property to solve the equations for x. So let's work on example 22. We're gonna solve using the 6. Yes, we're gonna use the one-to-one property, equal bases. That means we have equal exponents. E equal E, the same base. So we're just going to write down the exponents. The exponents here is going to be 8x minus 4 equals 6. Now solve this one. You're gonna move the 6 to the other side. So you're gonna add 4. So you're gonna move the 4. So it's going to be 8x equal 10. That means divide both sides by 8. So x is going to be equal 10 over 8. Can you simplify it? Yes, you can simplify this one by divide both by 2. So x is going to be equal 5 over 4. So we're going to type here, our value is fraction 5 divided by 4. The same thing with the next example, 23. We have e to the exponent x squared and minus 24 equal e to the 5x. We have equal bases. That means we have equal exponents. So we're going to write down the exponents, which is x squared minus 24 equal 5x. Now I need to solve this one. I'm going to move the 5x to this side, and I'm going to write down as a x squared plus is going to be minus. First of all, let's say minus 5x and minus 5x. That means x squared minus 5x minus 24 is going to be equal to the 0. Now it's a quadratic. How are we going to solve this one? We're going to open 2 parentheses equals 0. So 1x here, 1x here. We're going to put 8 because 24 is 3 times 8, and we're going to put a 3 here, minus, plus. Now it's going to be negative 8x, positive 3x. Add these together is going to be negative 5x. That means x minus 5 equals 0. So x is going to be equal 8. Sorry, x minus 8. And x plus 3 equals 0. That means x is going to be equal negative 3. So we have two solutions for this one. We're going to put 8, comma, negative 3. That's it for this example. Now let's see example 24. Example 24, complete the table by finding the balance A when P in dollars is invested and the rate and the T compound N. So they're telling you P equal 1500 and they give you this information and we need to find A, which is the balance. The rate is the important thing. The time is 10 years. The rate is R equal 3%. If you plug in a 3 in the formula, it's going to be wrong. You're going to say 3 divided by 100, and it's going to be 0.03. That's what you're going to plug in. 3%, you're going to divide 3 divided by 100, it's going to be 0.03. So the formula we're going to use, we need to find its compound, n equal 1, n equal 2, like annually, semi, quarterly, monthly, and daily, then continuous. So you're going to use formulas here and different formula when it's continuous. So when n equal 1, that means I'm going to use the formula A equal P 1 plus R over N Tn. Because compound when n equal 1, that means the balance is going to be 1500. 1 plus the rate is 0.03 divided by n, which is 1, and the time is t, tn, and times 1. So let's go here and plug in everything. Okay. So now we're going to say 1500 parentheses. Be careful here. 1 plus, I'm going to open another parentheses to write down 0.03 divided by 1, close this parentheses and close the second one. To the exponent, 10 times 1 is going to be 10. So it's going to be 2015, and we're going to round your answer to the nearest cent. So A is going to be 2015.87 cent. This is the first value. We're going to put it here. So 2015.87. Now, when n equal 2, we're going to use the same formula. N equal 2, that means our amount in balance in the account is going to be 15. 1 plus now 0.03 divided by n, which is 2, and 10 times 2. So we're going to say 1500, 1 plus, I'm going to open another parentheses, 0.03 divided by 2, close this parentheses and close the second one. To the exponent, 10 times 2 is going to be 20. And the result is going to be 2020.28. So our balance is going to be 20.282. That means 28 cents. The same thing when n equal 4, 12, and 365. So you're going to do the same thing here. But when n equal continuous, they're telling you continuous. That means you're going to use the formula A equal P E R T. That means A is going to be equal P, which is the principal. E, the rate is 0.03 times T is 10. That means A is going to be equal 1500 second function ln, which is the E function, and 0.03 times 10. And the result is going to be 2024 and 79 cents. 24.79 cents. That's it for this one. I got the second amount. When it's due, I got a 20.28. I needed to do the rest. And the last amount is a 24.79 cents. Let's check these values. For this example, we got it right, so just finish the rest of this table. Now, example 25, we're going to do exactly the same thing. Complete the table by finding the balance A when 12,000 is invested and the rate compound continuously and round your answer. So but how much the rate? Oh, we have the rate is 20%. Okay, let's work on example 25. So example 25, our rate is 2%, which is equal 2 divided by 100. So it's going to be equal 0.02. This is our rate. The principal is 12,000. And the time, we don't have time, but in the table, when time t, how much is going to be the balance? Because it's continuously, so our formula is going to be PE to the RT. Our future value when t equal 10 is going to be the principal. E, the rate is 0.02 times the time is 10, which is equal, that's mean A is going to be equal, that's a plugin, 12,000, the second, E to the fraction 0 to the exponent 0.02 times 10. So it's going to be 14,656. 14,656. How many cents? 83 cents. So this is the first value here. So it's going to be 14,656 and 0.83 cents. When t is a 20, A is going to be 12,000. E to the rate 0.02 times 20. That means the rate is going to be, the balance in the account is going to be, I'm going to do the same thing, the same function. We're just going to change the time from 10 to 20. So it's going to be 17,901.89 cent. I'm gonna round it, so it's going to be 90 cent. This is the second one. When t equal, the third one is 30. So the rate is going, the balance is going to be 12,000 a 0.02 times 30. That's mean is going to be the same thing. We're just going to change the time to 30, and it's going to be 21,865.425. So it's going to be 43. When t equal 40, a is going to be 12,000 e 0.02 times 40, and that's mean we're going to change the time to 40 now. So it's going to be 26,26706.49 cent. And the last one, when t equal 50, the balance is going to be 12,000 e 0.02 times 50, and that means the balance is going to be equal. Change 40 to 50. It's going to be 32,619.38 cent. So that's it for this example. We're just going to plug in these values. The second one is going to be 17,901.90. And this one is going to be 21865.43. And when it's 40, it's going to be 26706.49. And when it's 50, it's going to be 32,619.38. That's it for this example. There we go. Example 26. Let's check example 26. Example 26, they say on the day of childbirth, a parent deposit 35,000. Lucky child. In the trust fund and pay 60%. So our deposit, which is the principal, is 35,000. The rate is 60%. So our rate is going to be 60%, which is equal 6 divided by 100. And this one is going to be 0.06. Compound continuously, that's mean I'm going to use the formula A equal PERT. Now we just need the time. Determine the balance in the account on the child 30 birthday. That's mean the time is 30. And round to the 2 decimal places. So now we have all the information. We're just going to plug in. A is going to be P, which is 35,000. E, the rate is 0.06 times the time is 30. Plug in everything here. So it's going to be 35,000 e to the 0.06 times 30. How much the result is going to be? The account is going to be equal to 11737.66. So that's how much is going to be in the child account after 30 years. 211,737.66. Gonna do the same thing with example 27. 27 is going to be, what I'm going to do, I'm going to write down the information. Deposit 6,000. So I'm gonna write down, here is the deposit, which is 6,000. And let's see, the rate is 5.5. So our rate is 5.5%, which is equal 5.5 divided by 100, which is equal, so go ahead, 5.5 divided by 100. So it's going to be 0.055. So this is the rate you're going to use. Compound continuously. The balance will be given in the college after, you see, 30 years. So our time is 30 years. That's mean A equal PERT. The balance is going to be P, which is 6,000. E, the rate is 0.055, and the time is 30. That's mean the balance is going to be 6,000. The second fraction, then 0.055 times 30. How much is going to be? 3. A is going to be 31241.878. So 88. So we're going to plug in here 31241.88 because they ask us to round to the nearest cent. Okay. That's it for this example. The last example, assuming that the annual rate of inflation average is 3%. So now we have the rate is 3%. Which is equal 3 divided by 100, which is equal 0.03. Okay. Over next 20 years, that's mean our time is 20 years. Approximate cost C, goods, or service during any year in the decade will be modeled by this function. They're telling you here is the function. The cost function with respect to time t is equal P 1.03 and the time t, where t is the time and p is the percent cost. The price of the oil change for your car is presently, so here is the percent cost, 27.91. So that's mean P is equal 27.91. Now they ask you estimate the price 20 years from now. We need to find the price in the 20 years about this cost function. That means the cost in 20 years is going to be the percent cost, which is 27.91 times 1.03 to the time 20. So we're gonna plug in this part. You're just gonna say 27.91 times 1.03, close the parentheses, to the exponent 20. And how much is going to be 50? 1 second, to 20 years. That doesn't make sense. So the cost, it's 50 point to the nearest cent, so it's going to be 50.41. Doesn't make sense, but that's what we got. 50.41. It's going to be 50.41. There we go. That's it for this section 5.1.